Hello, hello, hello. My name is Josh. I'm a developer advocate here at Snowflake. And I'm really excited to be joined today by Sandeep Gupta, who's going to walk through how to productionize models in Snowflake and walk through the entire lifecycle of machine learning operations, all in Snowflake. So welcome, Sandeep.
Hey, Josh. Excited to be here.
Awesome. There you are. Thanks for joining. So
Yeah.
maybe can you start on giving us an intro about what is machine learning operations and how does that work in Snowflake?
Yes, yeah, absolutely. So Snowflake now has a very comprehensive platform for doing ML. And by that, what we mean is building a model, optimizing it, training it, and then deploying it and taking it all the way to production. So when we say MLOps, we basically mean like how to operationalize a model, meaning how to run it at scale on your production workloads, how to manage the life cycle of models, how to work with these models that you may be bringing in from outside. So we have a full set of tooling that supports that. And on this slide, you actually see what that whole stack looks like. So as you are going from your development journey to your operationalization journey, we have a set of libraries and APIs, the Snowflake ML APIs, which let you do feature engineering and model training. And then we have these tools for operationalizing the models, which we will talk a great deal more about today. And then all of this runs on our scalable compute. So you can run this on containers, on Snowpark Container Service, where you have access to GPUs and CPU compute pools. And you can use Snowflake's highly scalable virtual warehouses with any IDE of your choice. And of course, like with Snowflake Notebooks as a very easy and powerful way of developing these capabilities. So just maybe like double clicking on some of these things a little bit more on the ops side. We have a native integrated feature store product, which is generally available to all users. And Feature Store lets our users develop, create, manage, and serve machine learning features. And this is a very powerful and seamless way of organizing your features, making them discoverable, so your data scientists are not wasting time redoing or re-implementing things that others have already done. And it connects these features to your ML pipelines by serving them. Then on the model serving side, we have model registry, which is our main workhorse where all of your machine learning models reside. Think of it as a model catalog. So you log all of your models in there. You can store model metadata such as metrics. You can version them. And then you can run your inference through the model registry. And again, we'll see some examples of that. And then lastly, we have our full suite of observability products. So it's really important in production ML that you just don't throw your models over the wall. Once they're running, you sort of continuously monitor them. You see if they are working as they were at training time. And so that means that you want to track metrics over time. You want to compare different model versions. All of this is built in and it's supported in our platform. So these are some of the capabilities because of which Snowflake is an excellent place for you to run your ML workloads right next to where your data is. So I'll be happy to show you all of this, and we can switch over to a demo. So hopefully you all can see the screen. So I'm going to, for the purpose of this demo, I'll walk through this quick start, which takes us all the way from development to deployment and then operationalizing the models. And this quick start that I'm running is available for everyone. And if you go to our quick starts page, you will find this quick start right here that you can sort of run and follow all these steps along. So I've actually pre-run some of these cells in the interest of time. So what we do in this notebook is, and by the way, so this notebook is running on our container runtime platform. So if you go in here in notebook settings, you will see that this notebook is running on a special purpose container image that we create for our ML workloads. And it's using a GPU compute pool, so meaning that we have access to a GPU. And we can use this to run, to develop any machine learning models that we want. So here, like first we can install any additional libraries we need. I'm setting up my database and schema that I'll be using and the warehouse that I will use for running my data related queries. Then we have some imports and just setting up everything, initializing the session from our Snowflake notebooks. And then I'm loading some data. So for the purpose of today's demo, we are going to be looking at a data set that relates to loan approvals. So we have some mortgage lending demo data, and this data has been uploaded. So once you read this data into a table, you see that we have a bunch of rows where we have a loan ID, we have a timestamp for the loan, we have the loan type, and then we have other information about the loan, such as the loan amount, the location where it was, and then this last column, mortgage response, is a label that tells us whether the loan was approved or not. And we are trying to train a machine learning model that can predict whether a loan is going to be approved or not. So I'll just quickly go over some of the development steps and then like focus more on the operationalizing part in today's demo. But so here, like we're doing some classic data engineering work and some feature engineering. So like we are looking at the range of our timestamp values and converting some of those timestamp values and processing them. And then let's define some features of interest. So for the purpose of predicting loan approval, some of the things that might make sense are loan amount, the income and the income loan ratio. It may be relevant about what the average loan amounts are in that area, or what the mean, whether this is a high income user or not. So these are some of the things that we can calculate. And so we define these features declaratively as data frame operations, right, or data frame columns. And notice here that we have an average 30-day loan amount feature, and this is being calculated by a window function over the previous 30 days of range, and then aggregating those loan amounts and taking the average. So after defining all these features, we can now register them into a feature store. So the way we do that is we initialize a feature store, and then because these features are about a loan, we first create an entity. So we create a loan entity. So the features are going to model the loan object. And the join key for these loans are going to be the loan ID. So based on all this, we define a feature view, and then we can log this feature view into the feature store. So let's jump into Snow site. So here I am inside my Snow site, and I'm in the feature store section. You can have more than one feature store. So these are all the feature stores that we have here. So this is the feature store that I'm using. And here you see that this mortgage feature view is the feature view that I just registered. And if I go into this feature view, it has these 9 features that we just created. The really powerful thing about feature store is that if you have these time series features, like for example, this rolling 30-day average. Now imagine if you have continuously ingested new data, right? So new data is coming into your source data tables. So this 30-day loan aggregate amount will be continuously calculated for you on those new rows without you having to do anything. So it tells you here that this feature is running incrementally using a dynamic table. So behind the scenes, the dynamic table will keep on calculating as new data comes in. Right, so it's a very powerful way of doing this, and in addition, you also have the full lineage capability. So you can go into the lineage, and you see that this feature view is actually coming from this source data table.
That's awesome. For anyone not familiar with a feature store, can you just explain a little bit about how that can enable some like nice teamwork for machine learning things?
Yes, yeah, great point. So let's like go back to my feature store here, right? So so you see that I have other features here, and I can browse. So I can come to this UI, and I can browse all the other features that my data science colleagues might have defined. I can look at their descriptions. I can see what features there are, and I can quickly reuse that feature in my work. The other thing I can do from a collaboration perspective is I can go into search and just type in something like, let's say, loan approval features, and this is using Snowflake's very powerful universal search capability. And then if you go into feature views here, it will find the features that are already there that you have access to as a consumer of those features. right? So it's and then we look at some of the serving details as we get further down in this example as to how you consume features from the feature store. So let's move on. So after having defined these features, the next thing now is to create a training data set and to train a model. So I'm going to so here we have again defined these features and registered them in the feature store. So now to create a data set from feature store, it's really very simple. You first have to select what are the rows that you care about, right? So for example, let's say you might have a training data set that you want to create, and you want to select like 100 rows or 500 rows or something like that. So I'm just selecting the loan ID, the timestamp, the type of loan it is, and the label column, right? So this is data that you will have at training time or at inference time, right? Except for the label column. So from this spine, we can then now request features from the feature store using this generate dataset API. So you use the generate dataset API, you use the spine, and you ask it to populate it with the loan features. So after running this command, you see here that your data frame, which you had only this basic skeleton, that data frame is now populated with all the rest of the features, right? So the features that we said we are interested in: loan amount, income ratio, a high income flag, and the average 30-day loan amounts. These values were retrieved from the feature store and put into this data frame. So now you have your training data set, and now you can train a model, right? So after this, rest of the steps are standard open source model training stuff. So here we are doing some transformations. So for example, categorical columns, we are converting them to using one-hot encoding, and we are doing some numeric scaling. So after doing all that, we get our data set that we can then split on 70-30 test train split, which is a standard practice in data science. And then we can get to our model training, right? So now here, let's pick the very popular model, which is XGBoost classifier model. So we're going to be using XGB classifier here with some standard choices of number of trees, etc., that we have set here. And then we will pass in our training data frame to it, this xtrain PD, and we will fit this XGBoost model and get back our predictions. So after we run this, you can see here that we can calculate some accuracy metrics. So we can calculate F1 score, precision, and recall, and these are the values we got. So okay, so this looks pretty good. We're getting like pretty high accuracy here. So let's say we are happy with this model. So now let's think about how do we operationalize this model, right? So we have a trained model at this point. So this is where the model registry comes in. So we are going to now take this model, and first step is log it into our model registry. So here we have instantiated a model registry. Model registry is nothing but a schema in our database, which is going to house all of our models. And we are going to log this model. So when we log the model, we give it a version name. So let's call this a base model, because this is our baseline model. And we are going to also pass in the sample input data, which is our training data. We can set a descriptive comment about what this model is doing, and we can store all of the metrics, right? So after having done this, this model object is now a first-class object in Snowflake, and it has all the metadata Snowflake needs about your model. So let's go back into the UI again. So here is, I'm in the AI/ML section, I'm in the models tab, and this is my model registry. And this particular model, this mortgage lending MLOps, is the model that we just recently trained. So let's go in there. And we'll see in here that we have two versions. We have the baseline version and the optimized version. This baseline version is the one we just trained. And so you can see here that it has some information. It has the description that we added. It has these metrics that we stored with it: the F1 score, precision, recall. This also shows you the functions that the model exposes. So it has the predict function. If you expand this, it will show you that this predict function needs these 12 inputs. So these are the features that the model needs. And then it's going to be predicting whether the loan was approved or not. And we have also added automatically an explain function. And we'll see this later in the demo. This is a really powerful thing because it lets you explain your model's performance. It will let you explain the feature importance as to why the model is making the predictions it is making, right? So we did not have to write a single line of code to get this explain function. It was automatically created. Yeah. Uh, the other really powerful thing here, again, going back to lineage. So this model that we just trained, remember the data set that we had created from our feature store, and that data set came from a source data table and a feature view table. So you get the full end-to-end lineage of where exactly the source data was and the data set was, which is like an immutable object now. So anytime you would need to go back and create, let's say, a new model, you can reuse this data set and train a new version of a model. Sorry, Josh. I think you're muted. No worries. We'll catch up with that. So let me continue with this demo. So after having now created the baseline model, let's go through a typical workflow that is sort of bread and butter scenario in machine learning development, right? So here, like actually what I'm doing after this model is we are designating, because this is the only model we have, we are designating it as our prod version. And we are logging this model into the registry as our production version. So now let's go on. And we already looked at these model explainability functions. So now let's run our model on a different data set. So the other split that we had, right, the test split. So imagine if we ran this model on the test split and we got our accuracy scores, and they are worse off than we were on the training data. So this is something that frequently happens in data science. And what that generally means is that maybe your model is overfitting on the training data. Right? So let's see what we can do. So a frequent thing that is done is let's run hyperparameter optimization to try to come up with a more optimized model. Right. So we are going to use Snowflake ML's very powerful and scalable distributed hyperparameter optimization API. So we use our data connectors, and we use this tuner, which defines how to run this hyperparameter optimization. So we set up some tuner related parameters and the values that we want to search over. So this is our search space. We are going to search over the max depth of the trees, learning rate, number of estimators. And then using this hyperparameter tuner, we can then run this and get a better version of the model, right? And because we are using a GPU compute pool, this runs really quickly, and it finishes in a very scalable way compared to like single node training. So after having done this hyperparameter tuning, we see that, okay, now our test results are closer to the training results. And what that means is that this model is likely to perform better in a production setting. So let's now, what we'll do is we will log this optimized model back in the registry. We will store its metrics with it, and we will swap our prod version to be this new optimized model, right? So previously we had the baseline model, but we will use this tag prod to indicate that let's use the optimized model as the new model. So let's go back into the model registry again. So here inside, I'm in my models, and now you see I have the optimized model. And this optimized model is set as the prod version, and also it is set as the default version. And what that means is that anytime an inference request comes in, this is the version that is going to get used. Okay. So now let's also quickly look at model monitoring. So after having done the model training, we can then go on and attach our model monitors, right? So the rest of the code for doing that is here in this notebook. So I'm going to skip over that, but it's a really simple API to basically create a model monitor and attach it to your models. So after you do that, when you come into the UI, so you will see all the monitors that are running on your model. So let's look at this monitor for our optimized model. And so when you go into the monitor, if your model is making continuous predictions, you will see all of the accuracy metrics that you have selected right here as they are performing over time. And then so you can get counts of the predictions and actuals. You can get the accuracy scores. You can also get some drift measures. So you can do difference of means and other types of divergence measures for analyzing model drift. The other neat thing is you can compare two different model versions. So I can choose that I'm comparing the optimized model against the baseline model, and you can see how these two different models are behaving over time. Right? You can also do input feature quality drift. So if you go in here into settings, and if you choose the input features that we had, you can select any of these features and look at whether your input data is drifting. Right? So these are really powerful production ML tools for working with your models in production. So I think the last thing I will show you before we sort of come back to questions and discussion is that all of this is running. The model is deployed for inference in the warehouse, and warehouses they're great for CPU based model inference, but we now also support GPU based inference. So let's go back to our SPCS deployment section. So once this model object is trained, there's an alternative way of running inference, which is using Snowpark Container Service. And what that allows me to do is I can use a GPU compute pool with 4 GPUs, and I can deploy this model to run on that compute pool. That way, if this is a relatively small model, but if you have, let's say, more powerful deep learning models or even small scale LLMs or embeddings models, you can deploy them onto Snowpark Container Service and do really high scale, very performant inference. And so after doing this, we can now, there's a very simple API to do that. So you use the create service API and you choose your compute pool and you can just deploy this model as a service. One really powerful thing is that this also can spin up a REST API endpoint. So the model will be running on an endpoint, and you can then call that, invoke that through external applications, and you can run low latency inference using the SPCS model serving. So if you go back to our UI here, you will see that this optimized model, we show you that the inference service, it is running, right? So this model is deployed as a service, and that service is running. So if you go into the inference service tab, you will see here that this service is running and it's ready to receive requests, and it will serve out inference. So that's yes.
Yeah, in the example we just walked through, you train the model in Snowflake. Does this work similarly if somebody wants to bring in their model trained elsewhere?
Oh, a great question. Thank you. So absolutely. So we walked through a training workflow here where we develop the model in Snowflake. But a very frequent use case is maybe you are using external platforms, maybe you have pre-existing models and you want to bring those in. So if you go into our documentation page on the model registry, so just search for Snowflake ML model registry, you will come up to this page. In the model registry, if you go into the logging models section, you'll see this part about built-in model types. So as long as you have an external model in any of these formats, you can very easily just log it in and bring it in. And we even have some quick start examples here under examples and quick starts, where we show that if your model is in SageMaker or Azure ML or GCP Vertex AI, we have examples for all three of those scenarios that you can walk through and bring a model in.
Awesome. And is there some rule of thumb you would use for when you should bring a model into the warehouse for inference versus SPCS?
Yes. So the general guidance on that is, if you're doing sort of SQL-based data pipelines, right? You're doing some pre-processing, maybe after inference, you are chaining it with some post-processing or some downstream analytics. Warehouse works really well for those because we have a super optimized SQL engine. The other thing is that for relatively smaller models that fit into the warehouse memory, and you don't need access to a GPU, those are all scenarios where warehouse is a great platform for running inference. If you need access to a GPU, if you want to bring in your own pip packages, if you have custom dependencies that are not met in the warehouse, or if you have very large scale models, then SPCS deployment or if you need online inference, then SPCS deployment is a powerful way.
Got it. Yeah, it makes a ton of sense. I think there's a lot of questions in the chat, so maybe we can jump into some of those. So this first question is, can we store vector data as part of the feature store, or is it best to implement the feature store with already processed features?
Yeah, very good question. So the primary use cases are more with tabular sort of structured data. Vector data can absolutely stored with the feature store. We do have a vector data type column, and so you can put that in a feature store. We don't out of the box support things like nearest neighbor search, which is a typical operation you want to do with large scale vector data. But the good news is Cortex has Cortex Search, which is one of the most powerful ways of doing that. And so you can come up with architectures that combine your structured data, tabular data from feature store with Cortex Search as your vector store.
Awesome. I have another question in the chat. Does Snowflake have many model training capabilities, also sometimes known as MMT? And can you run the multiple model trainings in containers?
Yes. So this is a core use case that works really well in Snowflake. So first of all, the model registry supports what we call partition models that are really optimized for running. Actually, if I can go back to screen share for a second. Um, so in the model registry documentation, if you go into model serving, actually, sorry, in the model logging, using partition models. So right here, we walk you through how to store these many models or partition models using this custom partition model type of an API. And once you do that, then invoking inference on these many models is really straightforward because you just call your mv.run and you provide the partitioning key, and then that will run inference in a partitioned way. So this example will sort of walk you through that. And for training, you can set up your own sort of distributed training using the same framework. But on the container runtime side, we are building a new API which will really make many model training very, very powerful and easy. And that is available now as a preview, and it is coming soon in general availability.
Very cool. I love how flexible the workflow is. So I have this question from Saketh. It's how do you handle feature engineering with Snowflake? Do you use UDF, Snowpark, or external compute for this?
Yes, so all of these, right? Very, very flexible ways of doing this. Snowpark is a very common and preferred way of doing it because if you can write any sort of data transformations, data frame operations, Snowpark data frame is lazily evaluated. It is highly performant. We have a library of functions that support feature engineering. But the good news is that with container runtime, you can just use any open source library without any limitations, right? So you can use scikit-learn, you can use any other library that is of interest and do feature engineering using your preferred tool of choice.
Awesome. That sounds good. So I think that wraps it up for our audience portion. Is there anything else you want to wrap up with before we close out?
No, I'll just conclude by saying that that all of this is really meant for seamless, powerful, scalable use, and ease of use and single product experience is, as everybody knows, hopefully that is like something that we value deeply. So I really encourage you all to just play around with this. All of this material and quick starts are available. Try it out. Hopefully it works for your use cases. We are here in the product team and our awesome sales engineers and the field teams to help as needed. And would love to engage with the audience and see how this works.
Awesome. Thank you so much, Sandeep. It was great to see the entire life cycle, all the way
Yes,
from training all the way to serving and moderating.
Yeah, thank you so much, Josh. Thank you for the time. This was wonderful.
Awesome. Thank you. Bye.
Bye.